Okay, so now we're gonna turn our paper over and we're gonna do some, graph some equations in polar, some easy ones. Start out pretty easy. Okay, so, the first one though, on your homework, they're gonna ask you to write a point. Oh, so you guys can't see that. Write like point A, three different ways, like in three different coordinates. In three different coordinates. Okay, so let's say we've got our theta, right? And they give us 4 and 420. Haha, 420. Okay. Anyway, so we say, okay, well, what is 420? 420 is more than 360 degrees. So my first instinct always is to say, oh, well, I'm going to subtract 360 from 420, and then I've definitely got another coordinate, right? So minus 360, we need only go around once, right? So if I take that away, I have 4 comma 0. I'm going to borrow here. 12 minus 6 is 6. So we get 60 degrees. So that is definitely a valid point. So we are looking at this point here, 1, 2, 3, 4. So that's our point A. Okay, and we've already got one different coordinate. How about if we write it in radians? Yeah, you got it. That angle is pi over 3, right? So that's another way to write it. What if we did a negative value? So going around the opposite direction, that would be 300. Yeah, so we could do 4 comma negative 300. That's another way to do it. What if we did a negative r? What angle would that be? So we could go around all the way to here, right? And do a negative 4, because then that would put us back here. So that would be 240. So negative 4, 240 degrees. Could we write 240 with a negative angle? We certainly could, right? That would be negative 120. So I mean, you guys can see, I obviously did more than 3 coordinates really quickly. You can see there's a lot of different ways to write that same point. Okay, a couple other things I want to show on this graph. So we're going to, on this homework tonight, you're going to have a few simple graphs to do. So if you want to graph a polar equation, couple simple ones. Let's say if you just have r is equal to 1. Well, if r is equal to 1, right, we're on this circle right here. So if I say r is equal to 1, that's representing this entire circle. And so we just graphed it. R is equal to 1. Pretty cool, right? So this is I'm going to bubble this circle with radius 1. So a lot easier to graph a circle in polar than it is in Cartesian, right? You guys did circles in geometry. I'm sure you remember that. Let's do another one in light blue here. R is equal to 5. Can you do it? Of course you can, because it's pretty darn easy, right? 1, 2, 3, 4, 5. And then the hard part is kind of drawing a circle keeping on this, especially if you don't have polar paper. So guys, if you don't have polar paper, I'm gonna make some copies of this paper, both the note paper and the homework paper. And if you don't have a printer, you can just come by my house and pick it up, okay? And I'll leave directions on the Google Classroom for you. Okay. All right, r equals 5. We did it. Now, this is cool. What if we have theta equals something? What does that look like? So theta is equal to 330 degrees. Okay, so theta equals 330 degrees. That is this line right here, right? I'm going to do it. Let's do it in pink. I'll underline it in pink and I'll put it here. So this is 330, right? And r can be anything because we didn't define r, right? So r could be 1, 2, 3, 4, 5, 6, to infinity and beyond, right? So it keeps going and going and going. Could r be negative too? Yeah, absolutely. So theta equals any angle. It represents, a line. So pretty easy to graph a line too in polar. So that represents a line. So it represents a line. So 2 simple equations in polar. That's all we're going to do for tonight. I think maybe tomorrow we do some more exciting equations. Okay, the last thing we're going to study today is we're going to be able to find the distance between 2 points in polar. So it's a little bit more complicated. It's kind of like the distance formula, I suppose, in Cartesian. And I think you're going to like it. I think it's kind of cool. So, okay, so we're going to say, okay, I want to find the distance between A, which is 5, 120, and B, which is 3, 0. So I'm going to go ahead and graph these two. And I am going to ask you guys to graph them on your homework as well, because I think it helps. Okay, go to 120 and I go out to 5. So 1, 2, 3, 4, 5. So that's my A value. And then my B value was right here on 0. So it's 1, 2, 3. And we want to find this distance. Oh, I don't have a straight edge. I'm going to use my phone here. I should have a straight edge handy, and I don't. Okay, so that distance there, that's what I want to find. I'm going to call that distance AB. Line AB, right? So the cool thing about this is if I draw this triangle that this makes, so I'm going to draw this triangle. There we go, from the origin out. So we know some information here. This distance from the origin out to A is, you got it, is 5. So it's, I'm going to do this in general, r sub A, right? So whatever the r value is. Okay, and this distance from the origin out to B is, you got it, is 3, or r sub B. Now, look at this triangle. If we know this side, and we know this angle in here, this angle is B minus A, or A minus B, however you want to do it, theta B minus theta A. It's the difference between the two angles, right? We've got one side, another side, and the interior angle. How do we find this side of B, of AB? I know somebody said it. I know you guys did. Absolutely right. Law of cosines. Yeah, how cool is that, right? All right, so here we go. I'm going to go ahead and write the formula out. So I'm going to say AB that length AB is equal to the square root. Remember, it's this side squared is equal to these two, the sum of these two sides squared, plus RB squared, minus 2AC. Remember that? 2R sub A R sub B cosine C, right? And cosine is going to be cosine. I'm going to squeeze it in here. Sorry about this. Theta B minus theta A. Oh, we just fit it. And I can't quite fit my parenthesis, but you get the right idea. Okay, so here we go. Now we can just plug in our numbers. So AB is equal to the square root of 5 squared plus 3 squared minus 2 times 5 times 3 cosine of 0 minus 120. All right, and we do all that, we plug that into the calculator, right? Let's plug this one into the calculator anyway. So cosine negative 120. Okay, times 3 times 5 times 2. I don't know if I did that right. Or, oh, you know what? Aha, I didn't do that right because my mode is wrong. Yeah, cosine of negative 120. That should be negative 1/2, right? I can do that. That's not hard. Oh my goodness. It's a Tuesday. I have no excuse. Plus 9, plus 15, right? So the 2 times 1/2, negative 1/2, is going to be positive and then plus 15. And we get 25 plus 9 plus 15. So 25 plus 15 is 40, and that's going to be the square root of 49, which, oh my gosh, we know that one. It's 7. There we go. So law of cosines to find that. And you probably will need your calculator, right? Or not. Thanks, guys. Bye.